Section 11.4 deals with standard deviation, and it's a short section, but it's extremely important, especially when it comes to the SAT. So anyways, standard deviation definition, it shows you a measure, or it's a measure that shows you how data varies or deviates from the mean. Standard deviation shows you the spread, okay? So if we have a high standard deviation, it tells us that our data points are like spread out a bunch, while if we have an extremely low standard deviation, it pretty much means the data points are right on top of each other. So you can think of dot plots. High standard deviation, like you have your dots spread out all the way across the number line. Low standard deviation, they're going to be like pretty much centrally grouped. The symbol for standard deviation is sigma. So it's actually lowercase sigma. It's like a O or a 0 with a tail on the end. And here is the formula right here for it. So X would be the given value we're working with. X bar is the mean. And then N is the number of data values entered. So in order to calculate it by hand, we're going to go ahead and fill in this table down here because it makes life a little easier. They tell us that the table shows the number of cars sold over an 8-week period. We want to know how much variability does the data show. We want to find the standard deviation. Okay. So to do this, first off, I need to fill in the X bar. X bar is the mean. So remember, there's two ways you can go about doing this. You could go back to elementary school, which is what I'm going to do here, and know that the mean is the average. So I can go ahead and add all these values up. So 18, 25, 18, 10, 17, 15, 18, 15. Okay, so we go ahead and add them all up. And then there were 1, 2, 3, 4, 5, 6, 7, 8 entries. So we divide by 8. Okay, so the mean for our data here is 17. And the mean isn't going to change at all for any of these. So we're going to have 17 going all the way across the board. Our next row is the data value minus the mean. Okay, so we're doing top row minus second. So 18 minus 17 is going to give me 1. 25 minus 17 is 8. 1. Negative 7. 0. Negative 2. 1. Negative 2. Okay. Our last and final row that we're filling in here is X minus X bar. Okay, so our data value minus the mean, and then we need to square it. So really, you're just taking this row right here, squaring them. So 1 squared is 1, 8 squared is 64, 1. Negative 7 squared is going to give me a positive 49. Okay, remember, negative times a negative is a positive. 0 and 0 gives me 0, 4, 1, 4. And then you'll notice for this last one right here, we have a blank space in the bottom right. This symbol right here, this E, is sigma. Okay, so it's capital sigma. And that's asking us to find the sum. So for these first two rows, I didn't care what the sum was. But this bottom one, X minus X bar squared, we need to find the sum because that's our formula. Okay, it's the sum of every data value minus the mean squared. So going across this row, you're just going to add them up, and I'm going to use a calculator just to be sure. So we got 1, 64, 1, 49, 0, 4, 1, 4. Okay, you go ahead and add them up, double check, make sure you did it right. So 164, 1, 49, 0, 4, 1, 4. Enter. We have our sum to be 124. Okay. Last thing we're going to do here is we have to plug into our formula. So we know standard deviation is equal to the square root of the sum of our data value minus the mean squared over n, which is the number of data values. So plugging in what we know. We know the sum, so up top is going to be 124. Denominator is going to be 8 because there are 1, 2, 3, 4, 5, 6, 7, 8 data values entered. And then we need to take the square root of that. Again, calculator driven. So on the calculator, we're going to take the square root of 124 divided by 8. You can't see it because of the light. There we go. Square root 124 divided by 8. And it's going to give me a long decimal. I'm going to round to the hundredths place. So I'm going to say this equals roughly 3.94. All right. That's the standard deviation for this. Honestly, you can't do much when you just have one standard deviation value. Okay, typically you're going to compare multiple data sets and you compare the two numbers. So you'd say the one that has the higher standard deviation is more spread out than the one that had the smaller one. For this one, I don't know. You can say the standard deviation is 3.94. So we'd say like a typical point or a typical data entry is roughly 3.94 values away from the mean. But like I said, typically you'd be comparing two data sets and you'd say the one that has the higher standard deviation is more spread out. So that's example 2. You got to try it on the back. And then we're going to do one more. Okay, so looking at example 3, they tell us that the table displays the number of points scored during each of the regular season games. They want to know what are the mean and standard deviation for this data set. Honestly, we're going to let you use calculators. And if this pops up on the SAT where you would have to calculate standard deviation, they would let you use a calculator as well. So it goes back to how we were entering data the other day. You're going to hit stat, and then we're going to edit. We want to edit all of our data in list 1. I already have data here, so I'm going to go ahead, highlight L1, and then hit clear. Okay, it's real important you hit clear, not delete, hit clear, and then the down arrow, and it gets rid of all of it. And then we're just going to enter the data. So you got 24, 13, 10, 21, 18, 3, 27, 18, 20, 14, 7, 27. So 1, 2, 3, 4, 5, 6. Okay, get out. We're going to then go to stat, okay, because everything revolves around the stat button, which is right here. Okay, so stat. You're going to go to calc, because we actually want to calculate this stuff, one of our stats. Make sure L1's right there. It should be. And then we're going down to calculate, hit enter. All right, so for this, you have X bar, so our mean is going to be 16.83. Our standard deviation, okay, so you're looking for sigma. For some reason on the calculator it goes sigma x, but that's fine. That's what we want. Sigma x is going to be 7.34. Okay, make sure you're rounding properly, 7.34. And then our range is going to be max minus min. So you have 27 minus 3. It's going to give me 24. Okay, and that's because the range is max minus min. So we get 24 for the range. Okay. All right, so next question, they want to know, or they tell you that the team played in 2 postseason games. They scored 7 points in one, 14 points in the other. How do they affect the overall mean, standard deviation, and the number of points of the number of points scored all season? So we're going back to our calculator, stat, edit, and then we just have to edit or enter 2 more data values. So I'm going all the way down, hitting the down arrow, and then they scored 7. And they scored 14 in the other. So we're going to go ahead, stat, calc, 1 var, calculate. So standard deviation, not standard deviation, the mean is 15.93. Standard deviation is going to be 7.27. And then our range, our min and max stayed the same. So the range would be 24. Okay. So when you look at that, like it had the biggest effect on the mean, those 2 data values, because we dropped down almost a full point per game. Standard deviation didn't really have much effect on. Like it changed it by 0.07, 0.07. Range didn't affect anything at all. But anyways, like the big takeaway for this, standard deviation tells us how far the data is spread out. You can actually use it on your calculator. And like I said, typically we're comparing two data sets. You want to make sure the one that has the higher standard deviation, data is more spread out. The lower one, it's grouped closer together.